Hi, I'm Siqi from Computer Vision Center Barcelona. Today I will introduce our work, Generalized Source-Free Domain Adaptation. First, a quick recap to unsupervised domain adaptation, which aims to address the domain shift between a labeled source domain and an unlabeled target domain. However, one potential problem for this setting is that the source data may not always be available due to data privacy or intellectual property issues. Therefore, recently some people propose source-free domain adaptation setting, where the model is first pre-trained on the source domain and then perform adaptation with only the target data. But those methods do not consider keeping source performance after adaptation, which is of high predictive value in real-world application. Thus, in this paper we take a further step into this direction. We propose a new setting called Generalized Source-Free Domain Adaptation, where after source-free adaptation, the model is expected to give good source performance. In short, we have two goals here, source-free adaptation and less forgetting on the source domain after adaptation. Under this setting, we first pre-train the model on the source domain. Due to the domain shift, the target feature will deviate from the corresponding source feature cluster, which may lead to misclassification. To conduct a source-free adaptation, we propose local structure clustering to encourage consistent prediction between a feature and its few nearest label. This can effectively cluster the target feature. To decrease forgetting on the source domain, we propose to use randomly generated sparse domain attention. During source pre-training, we use a source attention AS to mask the output of feature extractor. For target adaptation, we use a ladder domain attention AT. Note that AT is only used for the forward pass. While doing the backward update, we adopt a source attention AS to regularize the gradients. This aims to avoid forgetting on the source domain by restricting the gradient flow into the source-related channels. In the experiments, we first show that our methods achieve state-of-the-art performance compared with related domain adaptation methods, and it outperformed the previous state-of-the-art short by over 2 points. On the generalized source-free domain adaptation setting, our methods also outperformed the short on the H value, which is a harmonic mean between source and the target performance. Here we show the accuracy curve during adaptation. It shows the source performance is quite stable during the whole adaptation process. Below the evaluation study on the sparse domain attention, the result shows the sparse domain attention does not only help to avoid forgetting on the source domain, but also is quite useful for target performance. We further check the ratio of the target feature, which have the same prediction with its 3 nearest neighbor, and the ratio among those features which have the correct prediction. It shows that the sparse domain attention is important for some classes. Removing sparse domain attention leads to significant performance drop for certain classes. Our method can be extended to continuous source-free domain adaptation, where the model is adapted to a sequence of target domains and is expected to have good performance on all previous domains. We show the results on Office Home under this setting. The first domain is a source domain. Here the results show that our method can effectively keep good performance on all previous domains. In conclusion, in this paper, we propose a new predictive domain adaptation setting called Generalized Source-Free Domain Adaptation to achieve source-free adaptation and also keep good source performance after adaptation. Specifically, we propose local structure clustering for adaptation without source data, and the sparse domain attention to decrease forgetting on the source domain. Thanks for your attention. If you are interested in our work, please check the paper and the code.